So, how do I set up this problem? How do I set this problem up? What did you do first? I get it. We have to long divide it. How would you set it up? So 80. Why does 84 go on the outside? Because what? It's what you're dividing by. Okay, it's your divisor. Okay, all right. It's after the divide sign. Okay, so if it's after the divide sign, it goes. Oops, wrong color. It goes outside. If it's before, or it's your divise E, it goes inside. Okay. Now what?
See how many times 84 goes into
91 first? Into 9 first. I look to see if the outside number can divide into my first digit. Okay? And in this case, no. Okay? So don't have to put a leading 0. Okay? Then I look first 2 digits. Yes or no? Yes. How many times? 1. So what do?
Put a 1 above the 1.
Put a 1 above the 1. Yep. Because organization, if you hadn't figured out, organization in long division is huge. Okay? Now what?
84 goes under 91.
Why does 84 go under 91?
Because you're subtracting it from the...
But why does 84 go underneath there?
You're just multiplying 1 by 84.
Yep, I got to take that number on top, and I got to multiply it by the number in front. Okay? So I take this blue 1 times 84, and that gives me the number that goes underneath here. And then I do what with it? Subtract. Okay? I get 7. Now what?
You dropped down to 7.
I got to drop down a 7. Okay. What do you mean it doesn't work?
84 can't go into 77.
So how many times does 84 go into 77?
0.
0 times. 0 times 84 is 0. Subtract is 77.
Drop down to 8.
Now I drop down the next number. Now what? Okay, how many times? 9. 9 times 4 is 36. So that's 6, carry the 3. 9 times 8 is 72. Plus the 3 that we're carrying along is 75. Subtract first. 22. Drop down the 9. Drop it like it's hot.
And probably multiply it by 2.
2. $168. 61? Okay. So this is, oops. $1,092 with a remainder of 61 would be an answer. 1,092 and 61/84 would be an answer. Right? Any other possible answers? Like, we could add zeros there and keep going until, like, if we had to round to a specific decimal or something like that?
Yeah.
Yep, very much so. Okay, or hopefully maybe it ends within 2 or 3. We could try that, okay? It doesn't, so I'm not going to. Okay, alright? Because I just wanted to get to the remainder part. Okay, but yeah, we could do that one. Okay? Alright? We're going to do that today. A lot. Okay? The downfall is it's not going to look like that because it's not going to be numbers. It's going to be polynomials. But when it's all said and done, you learned how to do today's stuff in 4th grade. Because this is 4th grade. Okay? Alright? Okay, so let's tweak it now to make it look like algebra. Okay? So we got that. Okay? 3x cubed plus 17x squared plus 21x minus 11 all divided by x plus 3. No different than the numbers. What comes behind the divide sign is my outside. What's in front of my divide sign, or what's in the numerator of my fraction, or what's in front of my slash, or however the division problem is written, that's the inside. My inside has one condition that comes along with it. And that condition is, you gotta think of how I said this before. Sometimes my brain hurts. Every exponent smaller not than every exponent smaller than the degree. What's the degree again? What's the degree of a polynomial? It's in your notes. Biggest what? Biggest power. Biggest exponent. Okay? So every exponent smaller than the degree must be represented. So if we're missing one. Okay? Like for instance, if this problem didn't have an x squared term in it, we would have to fill that spot with a 0x squared if it didn't have an x squared term. So every degree, or every exponent smaller than the degree, has to be represented. So the degree of this inside is what? 3. So I need an x cubed, an x squared, an x, and a number. Okay? All of them have to be represented. If they're not, I fill it in with a 0x to whatever power it needs to be. Okay? Let's do this. On the outside, we got x plus 3. On the inside, we've got 3x cubed plus 17x squared plus 21x minus 11. Okay, with me. Now, when we were doing numbers, we took that outside number and we tried to see how many times it went in to the inside number, right? Okay. Here with polynomials, you're only going to look at firsts. Okay? So I want x here to become 3x cubed. What do I have to multiply x by to get 3x cubed? 3x squared or just x squared? 3x squared. Okay? Now here's where I'm going to write my 3x squared. Everything's going to line up vertically. Whether or not you choose to do it in your brain, or if you need to have a little sidebar action, but you're going to take that 3x squared, and you're going to multiply it by the term that's out in front, and you're going to write it below, just like we were doing before. We took that number, in the first case it was 1, we multiplied it by 84, we wrote it below. Okay? So this becomes 3x cubed plus 9x squared. Then what did we do? We subtracted, right? Here now, this is the most important step. And this is probably where you're going to make a mistake. Okay? Because you're going to forget to change both signs. You're only going to change this first sign and forget to change the second sign. If you make a mistake, more than likely that's where it happens. Okay? It's just from 20 years teaching experience. When kids make mistake in long division of polynomials, that's where they make the mistake. They subtract the first term, they forget they have to subtract the second term. Okay? So, what I like to do is because you guys are working in one color probably, and that's fine. Pencil's a great color. Okay? Over-glorify that change, just so you know that you made it. Okay? Make it big. Okay? Make it bold, so that it's changed. Now, 3x cubed minus x cubed makes that go away. 17x squared minus 9x squared gets me 8x squared. And now what are we going to do? Drop it like it's hot. Drop it like it's hot. Drop that next term down. Rinse, lather, repeat. Now, instead of making x look like 3x cubed, I'm going to make x look like 8x squared. So what do I have to multiply x by to get 8x squared? Jenna? 8x. And so I'm going to put plus 8x there. So I write underneath 8x squared plus 24x. I need to subtract those, so I need to switch both of those signs. (8x squared minus x squared) makes that one go away. This gives me negative 3x. Then what?
Drop it down.
Drop the negative 11. Now I'm trying to make x look like negative 3x. So that's going to be minus 3. So that will be negative 3x minus 9. Change both the signs. Negative 3x plus 3x. Negative 11 plus 9 is 2. Oh, excuse me. Negative 2.
Did you put remainders on there like that?
Yes, and here's how we put remainders on there. Because normally we would say that this is 3x squared what did we say then? Plus 8x?
Yeah,
minus 3. Okay? That to me just doesn't, that's not mathematical like that. Okay? So what we say instead is 3x squared plus 8x minus 3 plus negative 2 over x plus 3. And that is a more algebraic remainder. I could have also gone minus positive 2 over x plus 3 there. You know what I mean? Because that negative sign can go on top, on the bottom, or out in front. Okay? Let's try one where we've got to add in a term. So outside is x plus 3. Inside is x cubed, right? Then I got to have an x squared term. Well, I don't have an x squared term, so that's going to be plus 0 x squared. then it's my x term, then it's my numbers term. Second biggest spot for a mistake, not adding in that place holding value. And that's more important when we get to synthetic substitution tomorrow than it is today with long division. Okay? Try it. That's minus 3x squared. Oh, whoa, just 3x.
Oh, yeah, I did. What happened? Did you get stuck in the...
I got x squared. It is minus 3x plus 5. And then if you wanted to go minus 9 over x plus 3, that's fine. You could have also gone plus negative 9 over x plus 3. Okay? Rinse, lather, repeat. Yeah. All right. Now, the reason that we have to learn long division, and we can't just go right to synthetic division, and trust me when I say this, synthetic division is much easier. Okay? 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 All right? There's only one hiccup in synthetic division, and then it doesn't do trinomials. You can't divide by a trinomial. So, or you can't divide by something that you can't find the zero of. So, you can't divide in synthetic division, you can't divide by a squared term. Okay? You have to divide by linear terms. So this problem is set up very much the same. I have to drop a placeholder of a 0x. Still trying to make the first look the same. So in this first one, I'm trying to make x squared become x cubed, and that's simply by multiplying by x. still multiply that by my outside value, and still write it underneath. Now, instead of changing two signs, I've got to change all the signs. Still drop stuff down the same. Minus 4x minus 8. Still, again, have to change all signs. So my answer here is x plus 4 plus 6x plus 1 over x squared minus x minus 2. Okay. Try that one. All right, talk to me. Outside. X plus 3. Inside.
Plus 0x to the 3rd minus 13x squared plus 0x minus 45.
Two placeholders in. Whoa. That was kind of funky.
How do you know, this is a stupid question, but how do you know when to put a placeholder in?
Every exponent smaller than the degree must be represented. If it's not represented, if it's not in the problem, you have to represent it in the problem with a placeholder.
Okay.
Yep.
Okay, because it's the same. That makes sense.
Okay. All right. First, x becomes 2x to the 4th using 2x cubed. Yes? So 2x cubed gets me there. So this becomes 2x to the 4th plus now 6x cubed. Right? What are we going to do? Switch both signs. Flip those signs. Okay? That gives me negative 6x cubed. Now what? Now what? The negative 13x squared? Okay, because it's negative in my problem, so. Then what, Colin? No, I asked you, Colin.
You gotta flip the signs. No.
What?
Not there yet, bro. It's minus 6.
Colin, let's pay attention and stop paying attention to Sam, okay?
Minus 6x
Right?
squared.
So I got to multiply first by minus 6x squared because I need this x to look like negative 6x cubed. So that's going to be negative 6x squared times x plus 3. So that's going to be negative 6x cubed minus 18x squared. Now, Colin, now what can I do?
Flip that sign.
Now I can flip that sign. Okay? That leaves me with 5x squared. Now what? Drop down what?
0x.
Drop down my 0x. He's tomorrow. Drop it like it's hot, guys, tomorrow. Okay? Okay? Got to make these now look the same. So that's going to be
5x.
plus 5x. So that's going to be 5x squared plus 15x. Flip the signs. Negative 15x. Can I get it? Oh yeah, I still got it in. So that's going to be negative 15. Flip the signs. Hey! Okay. So the answer here is 2x cubed minus 6x squared plus 5x minus 15. Right?
Yes.
Now, more importantly, what does... Oh, we'll go back to black. What does this tell me?
There's no remainder.
What now?
Well, there's no remainder.
Okay, so there's no remainder in the problem. Okay? So I get a problem where there's no remainder in it. What does that tell me? What makes it big time?
Oh,
So what goes in evenly? So the x plus 3 divides in evenly into that one, right? Which that makes then x plus 3 a factor. Two x to the fourth minus 13x squared minus 45. Okay? What else does that mean? I were to set this problem equal to 0, -3 would be a solution. How did I come up with -3 as a solution? Set what equal to 0? X plus 3, because remember we set our factors equal to 0. Okay? (13x² minus 45) is equal to x, what do we say, plus 3 times 2x³ minus 6x² plus 5x minus 15. Right? What can I do with that quad term? What can I do with this? What? Group it. So if we needed to factor it completely, we could keep going then. Okay? So that the fact that we got a remainder of 0 opens up a world of opportunities for us. Okay? Later on this week, actually I shouldn't say it, later on next week, we're going to learn that there's going to be 3 different bus stops. Okay? If I want to go down to the mall and get some bourbon chicken, okay? I could stop at John Muir, but I'm not getting my bourbon chicken at John Muir. I could stop at UWMC, still not getting my bourbon chicken there, okay? Or I could stop at the mall and get my bourbon chicken, okay? All right? Depending upon where the directions say to stop, that's going to tell you which bus stop you're getting off at, okay? If it just says divide the problem, okay, so if it just, like this one just said divide, then that's our answer. Okay? But if this problem said factor completely, then this blue line down here is my second bus stop. If it said solve, I could go one more step further and I could say, hey, let's set those factors equal to 0 and get answers. Okay? Oops, one too many. Homework tonight is a worksheet. I've already added it to the list of things due on Monday.